This is exercise 10C in lesson 3-2 in our textbook. This can be found on page 117 of the PDF. And you're asked to determine the value that satisfies the following probability for a standard, normal, random variable. Well, with questions like this, it helps me to picture what is described here by this inequality. So I've got the standard normal distribution. Of course, it's bell-shaped. It's centered at 0, and it counts out by standard deviations. We call these our z-scores. And when we have an interval where we're saying z is between negative z and positive z, we're talking about the middle portion of the curve. We know from the empirical rule that between -2 and +2 standard deviations in a normal curve, we should find about 95% of our observations. We actually want a little more than that, so we've got to go a little bit further out. So we're looking for the z-scores that have an area between them that is equal to 0.975. Well, let's think about it. We know that in a density curve, like a standard normal density curve, the total area underneath it should equal 1. So if this area here is 0.975, we're missing some, which must be in the tails of our distribution. Whoops. So to figure out what's missing, I need to subtract that 0.975 from 1, and I get 0.025. That 0.025 has to be split up into both of these tails, and since this is a symmetric distribution, it's going to be split up evenly. So to figure out what's in each tail, I need to take 0.025 and divide it by 2, and I get 0.0125. So that must mean that in this tail here, our area is 0.0125, and in this tail here, our area is 0.0125. Well, we know that the way that we determine a z-score, like z1, given the area below it, we can just use our inverse norm command on our calculator. That's second variables, and it's option 3. If you do inverse norm of the area below, which in this case is 0.0125, you can give it a comma, mean of 0, comma, standard deviation of 0, but you don't need to, unless you're using the other operating system where it will ask you for the mean and standard deviation, and you must give mean of 0 and standard deviation of 1. But when you do that, regardless of which operating system you're using, it's going to give you the value of that lower z-score, which is, in this case, negative 2.24. Well, since this is the middle 97.5%, then the upper z-score must be positive 2.24.